Hello dear students. So, in our last class I was explaining about qualitative analysis. So, what and all the different types of qualitative analysis we are going to do. How do we classify the qualitative analysis based on the sample size and the techniques, and also what are the different types of tests we are going to do, that is preliminary or dry tests and wet tests and spot tests. So, these things were discussed in our previous class, and in this session we are supposed to start the discussion of quantitative analysis. Okay. So, qualitative analysis is completed and qualitative analysis I am going to start in this session. Okay. So, after identifying the constituents present in the sample by qualitative analysis, so what we have to do is analyst means who perform analysis. Okay. So, the one who performs analysis is called as analyst. So, he will proceed to find out the quantity of these constituents. Quantity means it is a measure of amount, how much of that particular constituent is present. So, that is measured. So, that is why it is called as quantitative analysis. He is going to analyst is going to measure or find out the quantity of these constituents. Okay. So, estimation of the accurate amounts of the different constituents of the sample is known as quantitative analysis, and it is done by following methods. There are three types of quantitative analysis. They are, the first one is volumetric analysis, and the second one is gravimetric analysis, and the third one is instrumental analysis. Okay. So, first one, volumetric analysis, or it is also called as titrimetric analysis. Okay. So, I hope you all have performed titrations in your PUC classes. Okay. So, that is a method of analysis which comes under quantitative analysis, which is called as volumetric analysis or titrimetric analysis. So, what we are going to do in our titration? In a titration, so we are going to find out the concentration of the unknown solution by knowing the concentration of one solution. Okay. So, here two solutions are used, one will be used in the conical flask and another one will be used in the burette. Okay. So, to perform a titration we need a burette and a conical flask. So, the unknown concentration solution usually will be taken in the conical flask and the known concentration solution will be taken in the burette. Okay. So, known concentration means even if we do not know the concentration of the titrant, we are going to standardize it. Okay. Before performing any titration, we are going to standardize and we will find out the accurate concentration of any one of the solution, and with the help of that we are going to find out the concentration of the unknown solution. Okay. So, in volumetric analysis it is carried out by determining the volume Va of a solution of substance A, okay, which is required to react quantitatively with definite volume Vb of another solution of a substance. Okay. So, this is what is going to take place in volumetric analysis. So, if the concentration of one of the solution is known accurately, the concentration of other solution can be easily calculated by using the equation NaVa is equals to NbVb. Okay. So, this is a general form of equation what we are going to use to find out the concentration of unknown solution. So, here we should be known of any one of the concentration of any one of the solution. Say for example, if we know the concentration of a solution, that is A, the normality, concentration means it is represented in terms of normality. If we know the normality of solution A and also the volume how much has been consumed by that solution A, so we can calculate the normality of the solution B. So, volume will be pipetted out by ourselves. Okay. So, we are only going to pipette out how much volume is required and we will pipette out into the conical flask. Okay. And that volume will be known, and the titrant volume, that is which has been taken in the burette. So, that normality will be known. By standardizing we will come to know the accurate concentration or normality of solution A and how much of volume has been consumed, means how much of volume we have added through burette to the conical flask is the volume of A. Okay. By knowing this, we can find out NB, that is normality of solution B is founded. Okay. So, the amount of substance per dm cube, okay, how much amount of substance is present in 1 liter of a solution will be equal to the normality which I have founded out here, the normality into its equivalent mass. Okay. So, that gives how much amount or quantity in terms of mass, how much mass it has got. So, if we multiply the founded out normality with its equivalent mass. So, we are going to get the amount of substance per dm cube. Okay. So, this is how we are going to find out the concentration or the normality of the unknown solution in titrometric analysis. So, what is the procedure for the analysis? How to do this procedure? Volumetric analysis is, first we have to prepare a standard solution. A standard solution means whose normality is known, whose concentration is known. So, we are going to prepare the standard solution with the help of the equation, like how much normality is required. Say for example, 0.1 normal of sodium hydroxide is needed, how much volume is needed is 100 ml is needed. So, how do I calculate it? So, 0.1 into the equivalent weight of sodium hydroxide, that is 40 into 100 ml is required, 100 ml standard flask I am going to use, 100 divided by 1000. Okay. I repeat, the weight required to prepare 0.1 normal of sodium hydroxide solution is equals to 0.1 into 40 into 100 divided by 1000. If I do this, I will get certain amount of weight. Say for example, it will be 0.4 grams. If I take 0.4 grams and dissolve it in 100 ml of water, I will get 0.1 normal sodium hydroxide. Okay. So, in this way I am going to prepare the standard solution. The standard solution is a solution which is prepared by dissolving known amount of substance in the definite quantity of water. Okay. So, where its strength is exactly known. Since we only have prepared this solution, definitely we will be knowing the strength of this solution. That means how much normal it is or how much molar it is. Normality, or in terms of molarity, we can express the strength of a solution. Okay. So, we will be knowing it. A standard solution is taken in the burette, and solution whose concentration is to be determined is pipetted into the conical flask. Okay. So, this is what I said. Generally what we will do is, to a solution, the solution which concentration is not known, that will be pipetted out into the conical flask, and the standard solution whose concentration is exactly known, that will be taken in the burette. Okay. Completion of the reaction can be checked by using suitable indicator. Okay. So, here we, for volumetric analysis, we should use a indicator. Sometimes the solutions itself may act as indicator. Say for example, if we are using potassium dichromate or permanganate, so that solution itself will act as a indicator in some cases, whereas most of the acid base titrations or redox titrations, they require indicator to understand the end point or the equivalence point, or to check the reaction whether the reaction has been completed. So, this is checked with the help of using a suitable indicator. All the reactions may not be suitable for the analysis, it should follow some of the conditions. Okay. So, what are the conditions? The solutions should react completely under the experimental conditions. Okay. So, the solutions should react 100%. That means, so they should not we should not identify any dissociation problem or ionization problem in the solutions. It should completely get dissociated. Once all the solutions have been completely dissociated in the water, so then the solutions will react completely in any experimental conditions. Okay. And the next is the reaction should be fast, reaction has to proceed in a faster way. And the next condition is a suitable indicator should be available to indicate the end point of the reaction. For any titrometric analysis, if we are performing, we should check that whether we have the availability of a suitable indicator. So, that has to be satisfied, that is another condition before starting the analysis. And the fourth one is a sharp change in color should takes place at the end point. Okay. So, many of the acid base reactions will give or will result in a sharp change in the color, okay, which indicates the completion of the reaction or the equivalence point of the reaction. Okay. So, these are some of the conditions or the where the reaction selected for volumetric analysis must fulfill. Okay. And next moving on to the classification of titrations. The titrations can be classified based on the reactions involved during analysis. Okay. So, based on the reactions involved, we are going to classify them into 5 types, that is the first one is neutralization or acid base titrations. So, here one solution will be a acid and another one will be a base. Okay. So, that is why we are naming it as a acid base titration. So, what happens in a acid base titration? So, here neutralization point itself is called as a end point or equivalence point. Okay. Neutralization, that means acid and a base is going to react with each other, and how far or how long the reaction is going to proceed means, so till the solutions, the two solutions reach neutralization. Say for example, so you all know the pH scale. So, 1 to 7 is acidic and 7 to 14 is called as a basic solutions. Okay. So, 7 is the neutralization point. Say for example, if I am doing a titration of NaOH and HCl, definitely HCl is a strong acid, then it will have a pH of 3 or 3.5 something like that, and sodium hydroxide also is a strong base and it will have a pH of 9 or 10. So, here what happens is when we perform a titration between hydrochloric acid and sodium hydroxide, here, so the hydrochloric acid the H plus and Cl minus is the dissociation property of hydrochloric acid, and here the H plus is going to get replaced by sodium ion which is there in the sodium hydroxide, and thereby converting hydrochloric acid into sodium chloride, where sodium chloride is a salt, and this H plus is going to react with the OH minus, thereby liberating or eliminating as a water molecule. Okay. How long it is going to take place? Till all the H plus ions have been replaced by Na plus ions, sodium ions. Okay. So, all hydrochloric acid which has been present in the solution has to get converted into sodium chloride. Once all the hydrochloric acid is converted into sodium chloride, so that is what is called as a neutralization point or the equivalence point or end point. Okay. So, this is one example, and another example is, so here we can call it as strong acid strong base reaction. So, this is a titration which is an example of strong acid and a strong base, since hydrochloric acid is a strong acid and sodium hydroxide is a strong base. Okay. So, this is the example of strong acid strong base titration. Next is a strong acid weak base. Okay. So, sodium hydroxide is a strong base and oxalic acid is a weak acid. This is another example. And next is sodium carbonate versus hydrochloric acid. So, this is a weak base and a strong acid. Okay. So, these are the different examples of neutralization or acid base titrations. So, what is the indicator we are going to use in these experiments is, so to perform a strong acid strong base titration, we are going to use phenolphthalein or methyl orange indicator. Okay. So, to perform a strong acid strong base weak acid titration, phenolphthalein is the indicator used. Okay. So, I hope you have done the titration using phenolphthalein indicator. Okay. If you do the titration of sodium hydroxide versus hydrochloric acid by using phenolphthalein indicator, so there we will see the permanent pale pink color has to be formed. Okay, so that permanent pale pink color is the indication of phenolphthalein indicator, which shows or which tells us the completion of the reaction. In the same way, a weak base and a strong acid titration, if we are performing, means we have to use methyl orange as an indicator. Okay, so this is the first type of classification what we are going to do in the titrations. And the second one is redox titration. So in the redox titration, the examples which I can give is so potassium permanganate versus oxalic acid, KMnO4 versus oxalic acid is a very good example of redox titration. As I told, see here this KMnO4 permanganate itself acts as an indicator. That is what I told. Some solutions will act themselves as an indicator because permanganate is a orange color in appearance, so that will that itself will act as a indicator. And in the same way, potassium permanganate versus ferrous sulphate, this is also one example of redox titration where we are going to use diphenylamine as an indicator. Okay. So, this is the second classification. The third one is iodometric titration. Okay. So, here iodometric titration is a special type of titrations, so which requires iodine flask. We cannot do the titration in a conical flask. Just similar to the conical flask, we will get another apparatus, glassware, which what is called as iodine flask. By using that iodine flask, we are going to perform iodometric titrations, and most of the iodometric titrations are back titrations. Back titrations means, so here the two solutions will be used, and to the solution whose normality or the strength has to be determined. So, that will be reacted with the titrant with the help of iodine, that is potassium iodide we are going to use in these type of reactions. In iodometric titrations we are going to use potassium iodide, and the liberated iodine is back titrated with the help of sodium sulphate. Okay. So, we will use sodium sulphate and we are going to titrate to the liberated iodine. So, where we are going to use starch as an indicator. Okay. So, here starch acts as an indicator, and we are going to add it at the near the end point. When we are close to the end point, at that time we are going to add starch near the end point, and we are going to determine the equivalence or end point of the reaction. And the fourth type of titration is precipitation titration. Okay. So, it means as the name itself says, so here when a titrate is titrated with the titrant, so precipitation is going to get formed. So, the best example for precipitation titration is silver nitrate versus potassium chloride. If you use potassium chloride and titrate silver nitrate, so the end point is, or the reaction what is going to takes place will be the formation of precipitation. Okay. We can observe the precipitation, and whether all the AgNO3 has been precipitated to AgCl, that is checked, or the completion of the reaction is found out with the help of an indicator, that is potassium chromate. We are going to use potassium chromate as indicator in case of precipitation titrations. The fifth classification of titration is complexometric titration. Okay. So, here the complex which has been formed by the metal ions like magnesium, zinc will be determined with the help of EDTA. We are going to titrate the ions with EDTA by using erychrome black tea or xylenol orange or EBT. EBT is nothing but erychrome black tea. Okay. So, we are going to use these sort of indicators to find out the completion of the reactions in case of complexometric titration. Okay. You need not to worry much about what is the procedure, how to do the titration, how the complex is going to form, how precipitation will be formed. So, everything will be practically done in your practical classes, not in this semester, but you have gravimetric analysis, precipitation titrations, complexometric titrations, everything is there in your syllabus. So, when the time comes, you will study all the principles in detail. Okay. And next moving on to the advantages of volumetric analysis. So, volumetric analysis is very simple and accurate. So, we can get accurate if we are perfect in adding the titrant to the analyte. So, we will surely get accurate value in case of volumetric analysis, and equipments which needed to perform this experiment are very cheap, and specialized training is not required. So, it can be carried out on a semi micro scale. Okay. So, these are the advantages of volumetric analysis. And what are the disadvantages of this volumetric analysis? So, sometimes procedures are time consuming, that means it may take too much of time to identify, because in titration we should get concordant values. Okay. If we do not get concordant values, so till we get a concordant value we have to repeat the experiment again and again we have to do, and some indicators sometimes they will not work properly, will not find out the end point accurately. So, at that time we have to repeat the experiments 8 times, 10 times, 15 times. So, at that time the time consuming is very high. So, that is a main drawback or disadvantage of volumetric analysis. And there is a lack of sensitivity in volumetric analysis, and also accuracy decreases with the decreasing amount of samples. Okay. So, as a sample amount decreases, that means if we go to the lower concentration, that is like 0.01, 0.001, like that, if the concentration decreases, the amount of sample which is present in the solution decreases. So, the accuracy also decreases. And okay. So, these are the disadvantages of volumetric analysis. And next let us move on to gravimetric analysis. What is meant by gravimetric analysis? So, this analysis involves the determination of the amount of some constituents of a given sample by weighing. Gravimetry, gravity. Okay. So, gravimetry means we are going to weigh how much of amount of compound is present. So, we are going to weigh it. So, that is why gravimetry, the name gravimetric analysis. So, here we will determine the amount of some constituents which is present in the given sample by weighing. In this method, the constituent to be estimated is separated from the sample in a solid form which has known percentage of composition, and thus it is made suitable for weighing. Okay. So, since we are weighing it, so here the sample should be in a solid form. Okay. So, we cannot weigh it in a liquid form. Say for example, in a reaction precipitate is forming, means so that has to be filtered out. We have to filter the precipitate, and then that precipitate has to be dried in a microwave oven, and then we have to weigh it. Okay. So, that is why, so the most widely used method for getting solid form is a precipitation method. And okay. So, next so the first concept of gravimetric analysis is precipitation method. So, we have to precipitate it, then only we can weigh. Okay. So, that is why we will see the first method, that is precipitation method, and it involves the following steps. So, there are many steps what has to be followed in the precipitation method. So, the first one is the sample is dissolved in water to prepare solution of known concentration. First we have to prepare the solution. And okay. For example, let me take barium chloride experiment. So, this is estimation of barium in barium chloride by precipitating it to barium sulphate. Okay. So, this is the experiment. The example what I am going to explain here is estimation of barium in barium chloride. I am using barium chloride, estimation of barium in barium chloride. Okay. So, with the help of precipitation titration by converting this barium chloride to barium sulphate. And okay. So, this is the experiment. So, in your 5th semester you have gravimetric analysis, 5th semester you have gravimetric analysis, and there the experiment 1 is a estimation of barium. So, the same thing theoretically you are learning or listening now, you are we are discussing now, the same experiment will be conducted in the practicals in 5th semester. Okay. So, we will go in a brief way. So, what is going to happen in this precipitation titration? So, barium is precipitated as barium sulphate by using 1 normal sulphuric acid as precipitant. So, here sulphuric acid is used as a precipitant. So, barium chloride, so how the reaction goes? We will take a barium chloride, to that barium chloride 1 normal of sulphuric acid is added and it is thoroughly stirred. So, what happens here is, so the exchange of ions is going to take place. So, barium it will get completely dissociated since it is a strong electrolyte. So, it dissociates in a very good way, that is Ba plus and Cl minus, it gets dissociated. In the similar way hydrochloric this is sulphuric acid, this also will get dissociated, and the barium ion in the barium chloride. So, the chloride ions are replaced by sulphate ions and thereby the product what has been formed is barium sulphate. So, this barium sulphate will be precipitated out and what is left is hydrochloric acid is left. Okay, so, this is the reaction what is going to take place. In some cases the residue of definite composition is obtained by igniting the precipitant. Okay, so, we are going to ignite means we will use a heating mantle, we will keep the crucible in the heating mantle and we will ignite it. What happens is, so the only the Whatman filter paper or any other impurities which are present there, so that will be ignited and the rest what is left will be our barium sulphate. Okay, so, this is one example of precipitation titration. And the next example is the ferric iron is precipitated as ferric hydroxide. Okay, so, this experiment is also there in your 5th semester. So, the reaction goes in this way. So, here ferric hydroxide is heated. Okay, so, this arrow mark has to come here and this symbol, this triangle symbol means in chemistry we are heating. The reaction is proceeding in heating condition. Okay. So, what happens is we are going to get ferric ions, so that is Fe2O3. Okay, ferric oxide is going to form with the removal of 3 moles of water. The dried precipitate, so this Fe2O3 will be precipitated out. The dried precipitate or ignited residue is then weighed. Okay. So, this is how we are going to do the precipitation to find out the exact amount of quantity of that particular sample is present. We are going to weigh it. So, that is why once after precipitating it, so we will dry it through ignition or through microwave oven. So, we are going to dry it and once after drying we are going to weigh. Okay. So, that is why the name gravimetric analysis. So, the technique or the dried precipitate or ignited residue is weighed. From this mass the amount of required constituent is calculated with the help of suitable chemical stoichiometry relationship. Okay. So, with the help of stoichiometry we are going to find out how much amount of precipitate or a particular constituent is formed. Okay. The technique for obtaining a quantitative, pure, stable stoichiometry crystalline precipitate may be summarized as follows. Okay, so, to get pure, quantitative, stable stoichiometric crystalline precipitate, so what and all the techniques has to be used, so that is summarized in another 5 to 10 minutes. So, the first point is the sample should be dissolved completely in a suitable solvent and a dilute solution is used for the precipitation to avoid co-precipitation. Okay. So, we should not use concentrated solution in precipitation titration, we should use a lower concentration or dilute solutions, because to avoid co-precipitation. What is meant by co-precipitation we will see in our next classes. So, precipitation, that separate topic is there. So, there we will see what is meant by co-precipitation. And the second point is, usually an acidic and hot solution of a sample is treated with precipitant by adding dropwise with constant stirring. Okay. An acidic solution or a hot solution of a sample is treated with the precipitant, but we have to add it in a dropwise manner with the constant stirring. We should stir it, then only the precipitate will form in efficiently. So, this speeds up precipitation reaction and helps to get granular crystalline precipitates, and this helps us to avoid the co-precipitation. And the next is the precipitating reagent should be chosen to give a insoluble precipitate as possible. Okay. So, we should use a precipitating reagent very wisely. That means, the reagent as a precipitating reagent what we are going to use. So, that should give insoluble precipitate as possible, means once the precipitate is formed, it should not get soluble or it should not disappear when it comes in contact with more concentrated or more amount of water or solution. Okay. That means, the precipitate has to be permanent, the precipitate has to not get disappeared or it should not dissolve, it should not get soluble. So, that is what is the meaning of this sentence. That means, the precipitate should not ordinarily be digested for longer duration on steam bath. Okay. So, this is the another thing, and during precipitation optimum conditions like pH optimum conditions like pH, temperature, dilution, etc. must be strictly maintained to get quantitative pure precipitate. Okay. So, there are some other requirements or how efficiently the technique can be employed is given in your textbook. So, please go through it. The precipitate should ordinarily be digested for longer duration. So, that is what I told, it should be digested for longer time, and during digestion small particles deposit on the larger particles forming a regular crystal shape with least surface. Okay. So, the precipitates means if you see it in a molecular level. So, or if the precipitation is forming, that means there is a the formation of crystals. Okay. So, that crystals will overlap with each other and a regular crystal shape will be lost and it will form its own crystal shape and it occupies least surface area. So, hence co-precipitation by adsorption is minimized and the impurities trapped inside the crystal may also escape, making a precipitate less impure. Okay. Digestion promotes complete precipitation in the form which can be readily filtered. Okay. So, these are the benefits of digestion. Why we have to do digestion? Digestion means continuously heating for a longer duration on steam bath in order to avoid co-precipitation or post precipitation. That is what is called as digestion. Digestion means taking that precipitate and keeping it in a water bath or a steam bath for a longer time to avoid co-precipitation or post precipitation. Okay. So, that is what is called as digestion, do not get confused here. And if the solution after adding precipitants appears cloudy, it is possible that colloidal form of the solid is formed. It may be coagulated by further warming or adding more reagent. Okay. So, this is another thing what we have to notice down. And next is to check whether the precipitation is complete or not. After allowing the precipitate to settle, the drops of precipitate is added to clear the solution. If further precipitate is not formed, the precipitation is completed. Okay. So, these are the different techniques. You need not to worry much about all these things, it is not that much important, but just to go through it, how to attain or how to get a efficient and good precipitation, what and all the steps we have to follow to get a good precipitation is summarized here. Okay. So, in these 7 points what you have in the textbook and what I have explained just now. So, they have summarized to get or to obtain a quantitative pure stable stoichiometric crystalline. How we have to get it, how to get a quantitatively pure stable crystalline is summarized in these 7 points. Okay. So, next is a filtration. So, this is another step which has been involved in precipitation method. So, filtration, as the name itself says, filtration of a precipitate is done either by using ashless quantitative filter paper. We can directly use the filter paper, ashless filter paper or Whatman filter paper. So, to filter we can use it, and once after the filtration is done, so we can weigh it in the sintered glass crucible. Okay. So, we can use the sintered glass crucible and weigh it, and the next is the purification. The purity of the precipitate is an important aspect for successful gravimetric determination. So, that is why, so the precipitate after filtration may be contaminated with other substances from its mother liquid. So, So that is that means the precipitate with when it comes in contact with its mother liquid. Mother liquid means so which solution or which solvent we have used to prepare. Say for example, barium chloride and sulphuric acid experiment if we take. So barium chloride will be prepared with water. Okay. So here water is called as mother liquid. Barium chloride has been prepared by using distilled water, and sulphuric acid also prepared by using distilled water. But what happens when barium chloride and sulphuric acid both is going to react with each other, and the product what has been obtained is barium sulphate. So the mother liquid, so it may improve or develop the contaminated impurities in the precipitate. So that is why, so the precipitate after filtration may be contaminated with other substances from its mother liquid. Okay. The precipitate after filtration is washed with the washing solution. Washing solution will be distilled water or the solvent what we have used to prepare that solution to remove traces of impurities. The washed solution should contain a common ion to reduce the solubility of the precipitate, and the precipitate may be washed with very dilute solution as pure water tends to cause peptisation. Okay. So this is the next step what we are going to do in the precipitation method. So the first one is we are going to precipitate it, and the second is we are going to filtrate, and the third step is we are going to purify it, and the next step is drying and ignition. As I told, so once after filtering is done, once after purification is done, so then we will move on to drying. The washed pure precipitate may contain absorbed water or water of hydration. That water has to be removed. Okay. So if the filtration of precipitate is done by using ashless quantitative Whatman filter paper, so it is ignited in a previously weighed silica crucible. Okay. The ignition temperature or drying temperature is based upon the knowledge of chemical properties and thermal stability of the substance. The heating should be uniform and continued till constant weight. Okay. So this is how we are going to do the drying and ignition of purified precipitate. Okay. And the next is a cooling. So the sintered glass crucible will be kept in room temperature. You need not to keep it in any cold surface. So the sintered glass crucible or silica crucible containing residue is cooled to room temperature in a desiccator. We can keep it in a desiccator. Desiccator is the thing where it will be of it will be free from moisture sensitivity desiccator, and also it will have a lower temperature compared to the room temperature. So that is why the cooling will be more efficient if we keep the crucible in a desiccator. So cooling is attained like this, and next once it comes to the room temperature, or once all the hydrated particles which are present in the precipitate is removed and dried and cooled, so we are going to weigh it. The cooled crucible is weighed accurately. The mass of required constituent can be calculated using stoichiometric equation. Okay. So this is how we are going to do the precipitation titration. Okay. So do not get confused. So if my lecture is quite fast or speedy, do not mind, please. So you go through in your textbook, read it patiently, and read it again and again in the textbook. It is just like a theoretical part, no technical terms are there to understand. So if you have any doubts at any part, so you are free to ask me. Okay. So do not be nervous, or do not take it in a smoothie way. So read it. Okay. So if you read it again and again, so you will understand. It is just like a story, how to do the experiments. All these are just like a story. You need not to worry much about this. Okay. Once you perform these experiments practically, you will gain lot of knowledge, and everything will come to the clarity. Okay. So read it, and if you have any doubts, you can free ask me. So in my next class, we will start with the theories of precipitation. Okay. So I will stop it here. In my next class, we will see what and all the theories are involved in the precipitation. Okay. So, I thank you dear students.